Okay, welcome back to our second installment of our Houdini basic terrain building course. So today we're going to dig a little bit more into the erode system, the simulation part of it, and we're going to see how can we get a little more detail out of our environment right out of the simulation. So we're going to look at some additional noise patterns that we didn't look at last time. We're going to look at some features on the actual simulation node of how we get a little bit more out of that simulation to feed into our shaders. On top of that, we're now going to switch from using Karma and Karma CPU, the principled shader, to using MaterialX. A lot of the basic concepts carry over between those two different shading engines, but the node names are going to be a little different, and there's a few things that are not as easy inside of MaterialX. MaterialX is a great, more portable shading language or shading structure that can allow you to send shaders between different packages if they support MaterialX. But like anything that's universal, there's never enough U in the universal, right? MaterialX will work in certain ways. There are some nodes that are Houdini specific MaterialX nodes, so obviously those don't carry across. But we're going to dig in and how to use MaterialX to find ways to get just a little bit more out of our detail out of our setups, and also take the benefit of having XPU that we can render on, so that GPU will speed us up a whole bunch. All right, so let's get to it. All right, so as always, I'm going to go ahead and start off by saving my file. It's never good to work in an untitled file. You run into the risk of having a crash, losing work. At least this way, you might get some backups that will help you out. Okay, first things first, since we're going to be working a lot in Solaris, I like to stay in the Solaris build. One thing to be aware of is as you make adjustments to objects, if they're updating, if this stage graph is open, it will actually slow your scene down a lot. So you either need to close this down or jump into the traditional build layout for when you're not working in Solaris. So that's something to be aware of. I know there's probably things that they're trying to do. One of the things I've seen, that when you have the Solaris build here and you jump into a SOP context, this will change to the geometry spreadsheet to try to help mitigate some of those slowdowns. So before last time, we did all of our work in the object context, and we would just jump back and forth. A lot of times what I like to do is wherever my main focus is going to be for my build, I try to stay in that context and then use subcontexts. The reason for that is if I want to copy this into another file, I don't have to jump into a whole bunch of different contexts and copy. I can just grab all my nodes in one space, copy them, and paste them into another shot. So we're going to go ahead and build it that way for this week. So I'm going to go ahead and drop down an object network, right? As a reminder, we're in the stage context here. And I'm going to jump inside. I'm going to go ahead and drop down a height field. We'll just name this mountain or mountina. Let's go inside. We've got our height field already laid out. Let's frame this up. There we go. I'm going to go ahead and leave it at 1 kilometer for size, and we'll leave the grid spacing at 2. So let's just look at using some noise to get us started. Last week we used some points, and we used some tubes, and we kind of sculpted out something that was a little more art directable. This week we're just going to throw down and say, hey, Houdini, give us something using some proceduralism. So we're just going to use some noise patterns. So I'm going to go ahead and say height field noise, and I'm actually going to probably use 3 of these. So here's the default. We looked at this one last time, and it's fine. Sparse convolution does some nice stuff, but I'm actually going to start with this whirly cellular F2, F1, and I recommend that you kind of check out all of these and see, what they do. And you can see here we've dropped, like way down below the actual plane here, and we can remap that back up if we want to. We can do a height field remap, and we can compute this. And then usually what I'll do is I'll copy the parameter and paste this as a relative reference. You don't have to do any of this. Let's not do this, because sometimes I know that can be confusing. I'm just going to go ahead and do some math in here, and I'm going to say plus, I'm going to say plus 200, and I'll do plus 200 on this one. So what that did was just brought it up to, you know, more of with the, even with the ground plane. We're still below it a little bit. You know, we could do, you know, plus 250, I guess. That'll put us above. And there you go. So now we're up above that. When I look at this, there's some interesting kind of faceting that happens. Just, it looks mountainy. I'm probably going to go ahead and make an adjustment to this. Let's say, sorry, here. I'm going to come in and I'm just going to, let's just offset it. I want to see what other kind of looks I can get. Oh, I like that better. That one mountain was a little strange. Okay, so we're going to go with that. Now I'm going to drop down another height field noise. And we're just going to layer this up. That's with sparse convolution, the default of that. We can kind of see the change between those. That's fine, but I don't want that quite yet. I'm actually going to use now this Worley F1, and this is what that gives us. And you can see kind of what you're getting. Oh, sorry, I want to get rid of this. Right, so that's what would be by itself. This is putting those two together, and that's getting pretty cool too. Now I don't think I want this amplitude. I don't know that I want the scale. I linked these before, but this time I'm going to go ahead and break this, and we'll just change that and, you know, find something that kind of feels right. Yeah, maybe something there. Right, there's nothing, and just kind of give it just a little bit. Just push in on this a little bit. Now the reality is so many of these details get blown away in the erosion process. So you don't necessarily have to spend a ton of time trying to get these exactly perfect, and we can kind of see that later. We'll play with that. Okay, so there's that, and I'm going to do one more. So I'm going to do a height field noise again, and I think I'm going to just leave that like that. That's kind of doing some interesting stuff. Maybe I'll cut this in half. 250 by 250. Yeah, that's starting to look pretty cool. I'm going to do a height field distort by noise. Right, all the things. Yeah, that's starting to feel kind of nice and organic. Again, it's, you know, I try to avoid really spiky kind of features and try to have things that are just kind of subtle like this. All right, so now with this set up, let's go ahead and just drop down an erode. And we'll do kind of this as, we'll take a look at the basics here. One of the things we've talked about is the importance of using this freeze to set where you want that simulation to be. Now there's another piece of this that can help save some memory. You know, as this kind of computes, you can see here we've got all this cached. And the idea behind that is it allows you to scrub and see the erosion process and pick a frame. So if we were to turn this off now, you know, I could scrub through this and kind of find the frame I want. But the reality is that uses a bunch of memory. It puts a bunch of stuff into memory. So if we come over to simulation, we can actually turn off caching simulation. And so then what this should do is not hold as much information in memory. It's not going to worry about being able to make it scrubbable for you, right? But we've kept all this great info. So that's helpful, right? Okay, so we've got kind of our first go at this, and it's awesome. This is great. We've got some interesting shapes. Now, one of the things that I like to do is I like to work with the underlying bedrock of this simulation. So let's try it on this initial sim. We'll kind of tuck this off to the side. But what I'm going to do is I'm going to plug in to the second input. Let's just plug in our height field as it stands. Just waiting for that node to drop. And we're going to plug in the height field. As we jump between these two, you see that just plugging that in doesn't do anything. It's all the same. But we're going to come here to bedrock. And now what we can do is we can change this. Well, let's have one more. Set this to manual. Just for comparison here. If we take a look at this erodibility, it tells us that when this ramp is set to 0, it will make it so it does not erode. It treats it as rock. And so the leftmost layer is the out at the edge, like the outer edge of our height field. And the rightmost position on the ramp is the depth of that strata, the strata being like this erodable layer. So if we set this to something like here, based on this strata depth, it won't let it erode past this place. Okay? So we're going to take a look at these two different setups here. So already by setting this kind of strata, on both of them it hasn't changed much yet, but by setting that, you can see here that we're preserving a little bit more of that initial shape that we have. And we get these runoff lines that feel a little more organic, feel more appropriate to nature. You know, this here is one look, but I always look at this and the scale of this always kind of feels a little small and off to me. But now we see here we get something that feels much more like I would expect from erosion at a larger scale. We can see here with our height field plugged in, it hasn't changed anything yet. And that's because our height field is the exact same thing as what was being fed in. So now we're going to go ahead and just make some adjustments to our height field. So we'll do let's do a height field blur. And we're just going to soften this out. And we're going to do we'll do a height field mask with noise. And I'm going to change this to the Worley pattern. No, not Worley. Let's use Simplex. And then I'm going to change my element size so I get a little bit more repetition here. Doesn't really matter. We can play with this later and you'll see kind of what it does effect-wise. I'm going to say height field wrangle. Let's see if there's a height field VOP. We can do this in either a wrangle or a VOP. The reason I like a wrangle is because this is how fast it is. I say at height, right? So that's that channel that is the height field. And I'm going to say, we're going to say minus equals at mask times 10. So what this means is it's saying I'm taking my height field value, and when you say either times equals or plus equals or minus equals, it means I'm doing this operation on this value. So I'm taking my height field and I'm subtracting mask minus 10 times 10, or this mask. So everywhere that it's red, that's going to be a value of 10, so we're going to subtract a value of 10 from our height. So let's go ahead and hit that, and you can see there that comes down, right? So it kind of shrunk it down. So let's do a little bit more. Let's do 20. I'm going to do 25. Okay, so now I've got this kind of difference in my height field. Let's look at that inside of a VOP. So a VOP just allows us to do all that same stuff that we were just doing without having to worry about knowing how to code. So right now we have our height, and we're going to just pull in with a bind node. We're going to pull in that mask. Okay, so if you remember, we took our height and we subtracted the mask times 10. So we'll just put down a multiply here, and you can use multiply constant. You can use a regular multiply and create a parameter if you want. Let's do multiply and create a parameter. So I'm going to plug in my multiply, and then off of this input here, whoops, I'm going to put down a parameter, and we'll call this mult. Plug that in, and then we're going to say subtract, and we took our height field and we subtracted our mass times 10, and then this goes back in. This is going to re-export the height with this change. So we'll come here, we multiplied by, I think 25 is what we did, 25. And so now you can see we get the exact same result, right? Where this took just a couple of keystrokes, this took a little bit more setup, but it's the same idea. We took our height, we subtracted the mask multiplied by 20, and we sent that back out to height. Okay, so we can use either one of those now. And then what I want to also do is I'm going to put down another height field mask noise, and doesn't matter which one I take from here. We'll come here, and instead of sparse convolution, let's stay with simplex. We're going to increase this, and what I'm looking to do is I'm looking to create some kind of little jagged rocks that are going to pop up. And so it's really just this same kind of idea. So I'll do an attribute, or sorry, a height field wrangle. And this time I'm going to say at height, and I'm going to say plus equals, and then I'm going to say mask, sorry, at mask times 20. You see now we've got these little bumps that are coming up. So we've dropped some areas, we brought some areas up. We could play with all of this and find the patterns that make the most sense. We could do this with a VOP as well. So we're going to do a height field VOP. We bring in our bind node. We're going to bring in the mask. We will multiply. We're going to create a parameter. That way we don't have to keep coming inside of here. Right? You could just plug a constant in here if you wanted to, but just is a little cleaner this way. And then we are going to add this to our height field. So if we look right now, it's not doing anything. We give this a value of 25, and there we go. Now, oh, did we do a different value here? We did. We did a value of 20. So, value of 20. So now those match. Okay, so now let's plug this in to our height field erode. I'm going to hit manual for a second. Copy and paste this off to the side. This was what we had. I guess it doesn't really matter. It's going to be the same as this, so we won't worry about that. So you can see that we're starting to get some differences in where the simulation perceives that there is non-erodable bedrock. Right? So certain areas, because we've dropped way down, right? We've dropped what this bedrock is. So we've said, you know, in this area, I bet you if we look at this, there's a right? So in here, we've lowered this down a bunch. So we're saying our bedrock is way down here. And so then when it simulates, it allows that to drop through more. So this is just a great way of going through and adding additional detail. Now, I'll be honest, like when I use this, it's a little bit of like, you know, art by Yahtzee. And it's like, oh, did that give me the look I want? Let me throw some more stuff back in there and try it again. Other things that we can do is we can also use masks. So instead of using this erodibility of strata, we can come in and actually set using a mask where we want there to actually be types of simulation, right? So based on erodibility. So just for an example here, we'll take this one here, copy and paste, and we're just gonna use a single mask kind of for everything. Give this 1 second. So we'll say height field mask by noise, just to help give an example here. And I'm going to come into my hydro erodibility, and I'll just say mask on. In this case, this gives you a pre-populated value that it would look for. So you could have multiple channels or attributes set up that are unique to each thing that you're wanting to adjust. If you click this button here, it will automatically create some paint nodes for you, right? So you see that it made, you know, create this mask and mask paint. I hate painting. I love proceduralism a lot more than painting, so I'm going to get rid of that. We're just going to tell this we want to use the mask, so we'll just delete that, and so now it's going to use that mask node that we generate. And I'm going to actually do the same thing on the thermal erosion, so I'll just kind of hit these both with the same thing, and we'll go ahead and recache this. Okay, so already there we can see that there's a huge difference. We did get water accumulates, but we really got way less erosion, and that's because when we look at this, it's this big soft squishy mask. There's not really hard areas. So let's help to make this pop a little bit more. So I'm just going to go ahead and come down to our post-processing. Never mind, we'll do a pure amplitude and say 2. Increase our roughness. There we go, something like that. And now let's just run this again. Not nearly as much of the change as I expected from what it was. All right, it's always fascinating, the things that kind of don't play well together. So turning off the erode by strata made it so the mask actually behaved in the way that I was expecting. And part of that might have just been that we weren't seeing as much erosion when this was set, right? So when we had this, you can see here it's mostly water. We don't see a lot of the same kind of thermal erosion that we were seeing before because most everything here is kind of set to be bedrock. So we get less of that thermal erosion. It's mostly just hydro erosion. Where now here we're pulling from what this is, which has a lot more of that thermal erosion, which is wind erosion. So now you can see here using a mask, right, which is isolating these areas. You can still see there is some in here. There's some pink in there, and so what we get is a different look, right? So everything isn't so uniform all the way across. I don't really care about any of these. My interest is really in using our height field and modifying that so we can create greater detail in the simulation by allowing it to erode certain areas more than others. And so let's push on that a little bit more. Okay, so this is where we were at, right? So we're comparing here, which is just a general height field erode, nothing away from default. This is just dropping down a basic erode, which normally I would come in here and I'm going to adjust some riverbank, some of the settings in here, especially in the advanced area, to kind of help this get something a little closer. But what can we do with other tools that we're looking at here? So here's where we landed, right? Where it kind of gave us a different look. So what happens with these different noise patterns that we're using? So instead of here, let's take it and let's push this even harder, and then let's see what we get in comparison. So this is the result of that, and if we take a look here between the two, we end up with actually more hydro erosion or thermal erosion in some of these areas, but we start getting these kind of peaks, these little jaggedy rock feeling structures, which are fantastic. If you're looking at a mountain, there are mountains that look like this, but it depends if you're trying to get more of that detail out. So again, one of the things we love about Houdini is being able to branch off and create a new test node chain. So I'm going to do that, and so now what we're going to do is we're going to change this pattern. Already I like this kind of higher masking, which if we just look at this compared to our original height field, right? So this is our original height field, and so we're just kind of pushing some stuff up through it. Let's change that pattern, right? Let's change what this looks like. So we can do that in a couple of different ways. We can do that with changing its roughness, right? Actually, don't want more roughness. I want a little less roughness because I don't want little spikes. I want kind of bigger shapes. We can change its gain and then raise its amplitude, right? These are all things that allow us to change kind of the shaping of that. I'm going to change my element size here. I'm going to bring this up so I get kind of larger shapes because that's what I want to compare it to, something more like that. And now let's play with our bias and our gain. There we go. So now we're getting not nearly as many of these little kind of pokey bits. We're getting some more spread out, larger features. So let's take a look at what that gives us. Okay, so we can compare, this is our original. Here's our larger, more spread out, and it doesn't seem to have, quite nearly the effect. And then here's our smaller features. So depending on what you're wanting, this is kind of a play with it kind of thing. And I'd love to say that I understand exactly how it shapes this. But I find that it's sometimes a little less intuitive than you would hope. So there's a little bit of a kind of a chasing of that effect. So we can come back here, push our roughness maybe a little bit. Something like that. We could also merge in another noise pattern here, right? So if this is our noise, we could put down another height field noise. Oops, sorry. height field mask, noise, noise mask, mask. Oh, wrong thing again. Noise. And instead of add, we could make this as be the maximum. We could make this be a minimum, so we only get in certain areas, and then try to play with these. So we could come through and say, great, we'll make this something like that. And again, what we're trying to do here is we're trying to get rid of this really even pattern, right? That's one of the biggest things about proceduralism, is creating kind of layers of information to break that up. So now we've got this that controls our smaller detail, right? So if we push up our roughness, you can see that it's breaking up these shapes a little bit. We can come back in here and adjust, you know, our values to try to get something that maybe feels better than what we had. Maybe something like there. And so now this becomes what we're pushing through instead of this. And again, if there's not a right or wrong, it's about what is the thing that gives you the look that you're targeting. So let's take a look here. Getting some interesting shapes there. It's fascinating. I think some of those unique shapes that come out have to do with maybe some of the roughness, where you get kind of a mix of bigger shapes and some smaller shapes. Those smaller shapes kind of re-divert and you know, some of the erosion to go around features. There you go. So, you know, I pushed up that and gave more of these little kind of hyper details, and now we end up with, you know, little spikier things there that kind of drive the look of our mountains. But, you know, looking at this already in comparison to tumbling around this, you know, looking at this, like, our first reaction to this usually is like, all right, I've got I've got something that looks like erosion. That looks like a mountain. But then as we get down to here, all of a sudden we're starting to see more and more interesting detail. So we could then run another simulation on top of this. We could break out a different height field base, right, to kind of build off of bedrock, and run this again through a resample. And let's give that a try. Okay, so all I did was copy and paste our setup up above down below. So it's just the same thing over again. From the get-go, I'm not in love with it. So I've increased the resolution of my height field. So now I have 1,000,000 voxels to work with. The idea being that it will give us something else. Now this, I like when I look at this from coming from here to here, there's nothing in this that I feel gives me an advantage when I go to put shaders on this. And so, you know, we're now just going to carry heavier geometry, more expensive, for what? For some deeper cuts? Not cool. So what can we do? What can we do to make this a little bit better? So we're still doing the same thing. We're re-blurring this to kind of reset that up. We're putting the same noise on. So let's come in with all of our noise patterns. Let's just offset this by a value so it shifts where it happens, right? So we're going to change where, you know, and maybe our element size we change, right? So let's change our element size down a little bit, something like that. Again, there's nothing I'm seeing here other than I'm putting the dice in the Yahtzee cup and seeing what I get. So here's Here's this one. I'm going to elevate this one by 200, so it gives me a different place. And maybe I'll just push up the element size a little bit, and we'll come down. We'll change the bias a little bit. Then we'll grab this one here, same thing. We're just going to go ahead and move this maybe down 250 units. So just we're getting a different kind of area to affect. So there we go. So now we've got a new set of spiky places. And then maybe with this, let's not do so much roughness. All right, let's reduce that. And then maybe we'll bring this up to 100. I'm not really sure. I think that probably just expands the area that's kind of pushing through. And so now let's take a look again. So here's where we were. Let's hit reset. All right, so that got rid of some of those little jaggies. There's a few things in here that might be a little bit interesting, but again, not a terrible amount that I'm totally in love with. So let's do one more little trick here. We're going to actually take this and we're going to say height field remap. Compute our range, and I'm just going to go ahead and first I'm going to copy this parameter for our input, and I'm going to say, we're going to say plus paste relative reference, and we'll say plus paste relative reference. What that does, I'm going to subtract, sorry. What that does is just brings us up. So our lowest point is on the ground plane, and everything goes up from there. Not necessary, but something I like. Now, I'm going to take this whole thing, divided by 2. So when I come in here, the scale of this feels a little more appropriate. So sometimes when you run these simulations on these really steep mountains, you get these really deep cuts that don't necessarily look that great. You can either do a remap after, or you can do a remap before and go into like a final detail pass like we're doing right here. So see now all of a sudden we get down to this where this is starting to feel pretty cool. And it might be interesting to see what this would look like without our extra height field, without the bedrock manipulation. Let's see what that does. So again, this is where we, instead of running this on the lower elevation, right? Here we change the height, and then we did all this, and it gives us a certain look. Or what we can do is we can run it off of the steeper terrain, because we get deeper cuts and more kind of interesting erosion. We can see here, here's the one, here's the other. Again, just different, not necessarily right or wrong, just ways of getting interesting looks. And then we do our remap, right, for our height. And so let's take a look at what those look like. So again, not vastly different, but different. So you get a little bit of a different look based on whatever it is you're trying to do. So I'm actually going to go with this one here. I think it has some interesting things. I like some of these features that it generates. I like that I have a lot of debris that I can use to break up the look, you know, where I expect this to be kind of rock and snow, and then my debris is going to be my you know, my meadows and my plains and things like that. So now, just like before, I would come through here and add on all of my different masks that I'd want to use, right? So, you know, the first one being that I would want to generate is my slope mask, right? To identify, you know, what are the sides of my hills. So let's do that. So we're going to do a height field by feature, and this is again a little bit of a review, right? So there we go. There's the sides of my hills there. I'm going to go ahead and get rid of that and get rid of this. And I'm going to use the angle to kind of set where that happens. Now, last time we tried really hard to get down to where we had no kind of soft transitions, because it doesn't look very good in the shader to do that. The problem with using this that way is you're going to see, and we saw that in last week's class, you'll see that there's these kind of blocky transitions between those, because there's only so much resolution that we can get, and the less resolution that we have, the bigger the blocks are going to be. So with this now, like in MaterialX, we're going to do those transition breakups in the shaders themselves. So I'm actually going to leave it to have some graduation where I can between those different slope faces. So in here, where it's graduating from 0 to 1, and we have kind of that nice feathered edge, we'll use that with some noise inside of the shader to do that breakup. Okay, so then we're going to do a copy layer, and we're going to take our mask and call this slope. The next one that I want to do is I'm going to do a direction mask, right? So I'm just going to copy and paste this, and we'll turn off by slope, and we're going to use by direction. And I don't have a camera in my scene yet, so I'll kind of just set this up, and then depending on where I find my camera being best utilized, maybe something right like that. So there's my camera. So same thing, this is by direction. I don't think I think I just want a regular ramp. So here's an easier thing. Instead of dealing with those knots, just click that. So here there's a nice little fall off here we can see, you know, from those two, and that'll work just fine. Let's change our direction here. Now you can see with this one that we get those hard edges there no matter what, okay? And I don't really want those hard edges. I want this to have always kind of be soft. And so we'll call this direction before I forget. So how can I soften that? Well, I can do a height field resample. And so what we'll do is when you do this, you'll see that everything kind of softens, including the height. And what I don't want to do is I don't want to soften out all my other details. I might want to actually soften out the geometry a little bit. Usually what I'll do is after this is done, right, I'll throw a general on like this. Now if we look at this, right, we still have those kind of jagged edges. And so I want to do the resample. Sorry, wrong node. But I don't want to affect all my other attributes, my other volumes, my other height fields. So if this, like if I came up to like 5, you'll see it's kind of mushing everything out. So how can I do this but then bring it back? Well, we use a height field layer node, and we'll just plug this in here. We'll pull this across, and then what we tell it is we want to only replace our mask. And so when we look here, now we've kept all the sharpness of our geometry, but now we can independently soften that mask to get rid of some of those harsh edges. And we can do this for any, we can tell it any layer that we want to bring back after we've blurred it that way. So it's a way to kind of soften out, blur those attributes a little bit, so when they come into the shader, they're not so chunky. So, okay, another one that I want is I want to do my occlusion, so I'm going to put down a height field by feature again, and not slope, but occlusion. And I'm just going to reverse this direction. That feels pretty good. Again, we can see how chunky that is on that mask. So I'm really going to just copy this whole setup and bring that down so that way I can soften that out just a little bit. You could soften that out here with the ramp that we're remapping it with as well. So it just depends on how we use it. So maybe we'll do that. We'll call that that's interesting. So we'll do that. I'm not going to bring in the resample. I think that's soft enough. So we'll do height field, copy layer. And again, that mask is now going to be called occlusion. Then we should probably do an elevation and a floor mask. Some of those things are always helpful. So I'm just going to go ahead and pause. We've gone over that. I'm just going to walk through and I'll show you the results when I get those. Okay, so I've come through and I've made a few extra of these. So what do we have? We have our direction, which we saw. And then I came through and we did a mask by feature and made our occlusion. I think we went over that already. Happy with this. Soften that out. Now we come in and we do the kind of the gag that we did before where we break this up. We do a height field based on elevation, right, on height. And then we use that same kind of trick of copying that in using a height field layer node where we move the mask back into it, and this becomes our elevation attribute. Then I went and did a height field mask by slope, and I'm trying to target the areas that are flat versus the areas that are steep. And then I'm using a second with occlusion, and I'm setting the combine with existing to multiply, where the first one was replace. This one is now multiply, so it multiplies the results of these two against each other. If we were to take a look at this and set it to replace, this is the occlusion that I was using, and then I'm setting that to multiply. So it's just kind of where those two things are in common. Then I'm using a remap, height field remap of the mask, and I'm just kind of, cranking this up. And then it gets a little chunky, so I'm using this to soften it out. That's probably a little much. Something like that to kind of just break up some of those hard edges. And then same thing, using the height field layer node to copy that mask back in. and then we're renaming that to be floor. So now we've got water, sediment, bedrock, we've got all kinds of things that we can use, and these new channels. So let's now get past, we've now kind of gone through and looked at some of these additional tools that we have for adjusting the look of our simulation itself. So now let's go into our MaterialX and look at what that means to build. So let's go ahead and put down I'm going to put down a heightfield convert. I'm going to do 2 of these. I'm going to branch this out and then I'll merge them back together. So I'll copy and paste this over. This one, its density is going to be 0.1. We could probably go even less than that, 0.05, just to give me representation. Again, we've covered that already. And I'm going to go ahead and put down a name. And for this, I'm actually going to not just give it a regular, like singular name. I'm going to give it more like a path here. And you'll see that, where I think last time we were building this using the component builder, this time we're just going to build it from scratch to kind of see the difference of those two things. So for the name, I'm just going to call this for now, we'll call it mountain. And we'll call this one, also, we'll do the same, copy and paste this. And I'm going to put an output node for each one of those. And you have to change that to be its own index. All right, so now that that's set up, I'm going to come back into my stage here, and I want to bring that in. So I'm going to go ahead and use a sop import to pull that in. So I'm going to drop that down, and I'm going to go to the path of where I built that. So mountain, and then we have output 1 and output 2. So I'm going to grab zero, output 0, and we'll do. So there it is. There's our high res, and you see that it comes in. It's called sop import 1 mountain. That's because this is using $OS. We could change this. We could change this to be whatever we want. So we're going to call this. We'll call this geo, and then we'll have a render area that it's going to drop into. So there we go. So geo render mountain, and then I'm just going to copy and paste this down. And for this one, we'll just grab input 1, and I'm going to connect these two, and this is going to be proxy. And so now we have both of these coming in. So we have our proxy mountain, we have our render mountain, and now we're going to put down a configure primitives node. And this is going to allow us to go and kind of pick these different ones. So we'll grab that one first, the proxy, and we're going to change its purpose to be proxy. And then we'll grab another one, we'll just copy and paste. And instead of proxy, we're going to grab our render mountain. We'll drop that in there. And this one's going to be render. All right, so we're going to, sometimes you have to kind of shake this a little bit to get it to kind of take. What we're looking for is right here. You can see under the computed purpose, it says render. And there's some built-in stuff with how this works. So now if we go to Karma XPU, when this renders, it's going to render just that render mountain. See, we don't have that kind of soft geo poking through. And then when we go back to our Houdini GL, it should only be showing the one. I'm guessing that if we were to restart this, it would be fine. There's just for whatever reason, there's a weirdness here. It's a little bit of a glitch. So maybe we can try clicking away for a second. Okay, so let's just view from a different place, and then we'll come down and view. There we go. So you see these are all checked off. The default is that proxy and guide will show. So now there you go. So we just had to kind of reset the viewport. Sometimes it gets stuck. And so now we've got this little setup here, and we've got our proxy is what's always going to be showing. So it helps to save us on GPU usage. And then when we hit render, it's going to switch over and render our high-res geo, which is fantastic. Okay, so I'm going to stay on GL, and I'm going to drop down a dome light. And let's just start with a dome light for now. And I'm going to pull in a texture. This is one that I already have, an HDR. To pull that in, and we'll go to XPU. And there you go, that's great. So we've got that set up. So now let's look at how can we go about shading this. And let's do a scene import cameras. I'm going to put this at the top of my network. That way, wherever I'm at, the camera is always accessible. Because if I put it down here, but if I'm viewing up here, there won't be a camera to be able to pick from. So the root object is going to be this object network 1. And then now it's going to grab all of our cameras, and we can see that it's now popping up over here, right? So if you want it to be something fancier than just the slash, you could just, you could do cameras, so you have a little bit of like organization here. So when we look, right, we have cameras, camera 1, lights. So now we can look through our actual camera. So there we go. We've got our view set up. So now let's start putting our materials on here. So we're going to do MaterialX. So let's go ahead and do a material library. And let's jump inside. So by default, this will create the materials, but it's not going to assign it to anything. We've done this already. And I'm going to come in here, and under MaterialX, I'm going to create a USD material builder. When we jump inside, we've got a standard surface, we've got an output, and some displacement. So with building this, we don't have the kind of standard pre-built shader that allows you to just plug in all of your textures. So we're either going to build this a single texture at a time, or there are a few nodes, like we could use the PBR texture set. And this kind of has a UI, that allows you to kind of point to a bunch of textures, right? It's got some default values for when those aren't there. I've not used this. We could try it and see. There is a place where you can plug in your texture coordinates. So we'll experiment with this for about a second and see what it does, and then we're gonna move on from there. So going back to how we were using the bridge before to bring in our materials from the Epic, that is not going to. There's not an option here for us to say to use MaterialX. I believe, like down here, if you correct, it used to be that this might have given you that option for the USD material, but this is currently broken in my setup and I haven't taken the time to fix it. So that's okay. We can still kind of grab shaders and pull them in. So this would be probably an interesting one to send over. So I'm going to go ahead and send that. This is that kind of snow-covered ground. I just like the visual breakup that I get in there. And then I'm going to go grab like this powdered coal and soil. I like that one. And then I'm going to go grab a dark Icelandic rock. I want my colors to kind of feel like they relate to each other. Now, if you do a surface that is like really large scale features, then you're going to have to tile it a lot. If you do something that has a higher frequency, you don't have to tile as much, which is kind of nice. So sometimes we can cheat and use these ground-based ones to feel more like a mountainside or what have you. So it doesn't always work. Sometimes it does. So something like this is going to be interesting to use. Things that are very linear like this sometimes will look strange. So let's see. Some nice dark. This looks good, so I'm going to send this over. And let's see, we need one kind of dirt kind of feeling stuff. That one might be interesting too. We'll send that over. Okay, and then snow. I'll do one. We'll do two snow. That one and that one. All right, that should be plenty. This is going to take a bit to set up. So we have 6 shaders, and really all we're doing with this is we're going to be using this to go grab where my textures live on disk. That's really the main reason is that I bring these in, because these shaders aren't usable. So I've got these. So I'm going to start with this one here, my Icelandic cracked rock. I've got to have better than 2K, don't I? Oh, how terrible. Icelandic cracked rock. Is this the one? This was the one. 8K resolution, download. All right, we'll let that cook in the background. So maybe we'll start with snow. Snow will be easy to see. So let's start with snow, and then we're gonna, there we go. I'm gonna go to my textures here. Oh, does that also, no, this one should have, oh, I've been operating at 2K all this time for some of these assets. Windswept snow. Let's download you too. This one will be though. There we go, 8K. So we'll start with this. I'm just gonna copy that path. And now I'm gonna jump back over. I can either click and go to my stage and click through, or I can click this back arrow and hold it. And there, it gives me kind of a memory of the places I've been. This is like my browsing history in the internet. All right, so let's test this one here. I'm going to use this as my base, and now that I've got that, I can just take it and paste it here. And the cool thing is if you know what you're trying to grab, right? You can come in here. We see we have albedo, we have displacement, normal, roughness, and specular. So I don't really need metalness. We do have specular color. We do have a specular roughness. And then we just know what these are named. We can just type that in, right? So specular, roughness, normal, displacement. So this is going to be specular. Oh, cool. It's auto-completing for me. Yay, that's rad. That's super cool. So this we want to be our specular roughness. I'm going to use the rat. Oh, but I don't want the 2K. I want the 8K. I'm not doing anything with coat, subsurface, or emission, occlusion, or opacity. Great. So now we come into bump, and we see that this is going to be a normal. And so we can just, again, paste that same thing in here. I'm going to delete that and type N for normal. That's a cool feature that I didn't know it had. So now we've got this set up. I can just drag these things over and connect them up. So I can just take this base color, which we know we have that. We have a specular color and a specular roughness. So we'll connect those. And we have a normal, so we'll open up the geometry here. And I believe this should be a tangent normal. And I think that's all that we had, right? So we had, we'll play with that. I don't, before I start just changing things like crazy. So we should have 4 connections there. Now, here's the rub, is we're gonna have to bring in an additional texture node. So I've not tried, there's a tiled texture, right? So there's tiled image, and then there's just image. Right? So you see here under the main difference is we've got some built-in tiling UV attributes. So I think we're probably going to skip this one, and we're going to use our regular material here. And for its file name, I'll paste this. And oh, so awesome. And this is going to be, for its color, is going to be a float, not a color. And then we'll plug this into displacement. So now, in theory, we've got a shader kind of set up. Let's give this a test. So we'll call this MaterialX mountain. We'll come back up. We're going to make this assigned. I like to just go ahead and plug it in. So not that material library, except in our geometry path, we're going to go ahead and just put that on the render geometry. Okay, let's take a look here. So I'm going to just hit the Houdini GL, restart that, and then we will go back to XPU. While this is cooking, I'm actually going to drop this down, and I'm going to open up my little snapshot. That's going to allow me to drop a couple of images here. Once we, it helps to be able to look back and say, oh, how was this looking before to what it's looking like now. Okay, so we've got that rendering, and we've got an attached shader. This is fantastic. So let's take a look at, and again, I've actually not used this node before, so we're going to try something. We're going to drop down a texture coordinate, and now what we can do is we can adjust this. So we can do a multiply, and we'll plug this in. So it's a vector 2. We're going to plug this into our texture coordinate. And now the difference here is before, inside of the principled shader, we were setting this to like 0.1, and it was making the pattern get smaller. And I think what that was is there's, if we look at that the tiling image, there's this real world image size. I believe inside of the Karma shader is doing something similar to this, where the idea is like, what's the real world image size of this? And you can kind of use that to set the units of what this is. So we're going to take a snapshot here, so that way we have that to go back to. It's always good, so that way you can remember. And let's make this, I believe we want to multiply this up. So let's make this a value of 10. And there you go. So with our value of 10, you can see that our frequency went up quite a bit. So this is actually a pretty nifty, like a much cleaner way than what I was planning on showing, which was to just use a bunch of tiled images. So you would set up one for each shader, and then go from there. Now, the reality is once you have this, how do we now start adding in additional materials, right? I'm going to move this all kind of, give ourselves some working space. Our displacement still doesn't look great. Part of that might just be scale, so we could try punching up the scale of that. The other part of that could be that we need to increase our dicing quality in order to get more detail in that. So that's part of it. We push it up. Although, here's the fascinating thing. Looking at this, it very much appears like the displacement, this image, is not liking this trick in the way that this image is. Because these shapes look very much like they belong to our unmultiplied. So let's just try cutting this. So we're going to snapshot this, and then we're going to cut these. All right, so there's our extra. So I'm going to right click and say view image, right? So that's our original. Here's our displaced and higher frequency. And then here's this guy. Maybe not. Maybe it was working. Doesn't seem as associated as I kind of once felt. All right, so we're going to put that back to the way it was. So we'll plug this in here. We'll plug this in here. Okay, so now I'm going to delete this. We're going to run with this. This is going to be our method. So I'm just going to take, and I'm always going to pause this. When you start doing heavy stuff, pause your render. Having this running all the time really increases the number of crashes that you're going to see. So I'm going to go ahead and copy and paste this down. And for our textures, now I'm going to go grab we're going to grab, let's use snow. Snow-covered ground. No, let's use this fresh wind-swept snow. So I'm going to copy this. I'm hoping that's finished downloading. Come back to here. And for this first base color, I'm just going to hit paste. And I'm going to try just deleting all this and see what it gives me. And do we have some 8K? We have some 8K. Woohoo! Super exciting. Look at it. We got all kinds of stuff. I downloaded a lot more stuff. Okay, so this needs albedo as... Oh. Albedo. We don't have an EXR or a rat, so I'm going to use the EXR. Usually, like if I were to send this again to Houdini from the bridge, right? So this was our windswept snow. Is it this one that we sent? I can't remember. It's one of these two. I know this was one. There's fresh snow. Anyway, if I were to hit this again, right, and resend it back to Houdini, it's gonna, if you have it set to, convert, it's gonna reconvert those textures. So just know that, you know, that's all you need to do. For now, we're gonna stick with the EXRs. I don't think they're as efficient as the rats. I think once we hit render, it's gonna do that for us. It's gonna try to fix that. Okay, 8K underscore albedo. Awesome. Now I'm just going to grab this whole awesomeness and copy, paste right there, and this is going to be specular. Paste this right there. And this is going to be roughness. And then we're going to get our bump. And I bet I just need to turn that bump scale up too. And paste, and this is going to be normal. We'll just turn this up to 1. Let's see. Woohoo! So fun. Okay, so we've plugged all those in. Now the last one is come and get our displacement. So we're going to paste that, and this is going to be displacement. Okay, so now we've got our 2 shaders. Awesome. Little more setup here, right, than just getting something sent to us by the bridge. We've got to kind of build this up. So now we're going to put down a mix node. So there's a MaterialX mix node. And when you look at this, it's calling for a float. But the reality is whatever we plug into this, it's going to change to that and say, great, you want us to do a surface. And you can see the signature change to surface. It automatically changed to what we need this to be. I believe, like we just went over and discussed about with the Karma, the layer mix node, you have FG and BG, and the mask that you put into that, anything that is white is BG, and anything that is black is FG. I'm pretty sure this is the reverse, and we're about to try that out. So, before we would use a bind node. Oh, no bind node. Okay, cool. So what do we use here? There's 2 different ways. We could do a USD, let's see, import USD, not material. There's a property. Well, I can't even remember. So, but there's going to be a, oh goodness, I'm forgetting. It is a geometry property value. There's another one that's a USD something or other that pulls from the USD. Now the USD one will make it so you have to be working in USD wherever the MaterialX gets sent to. But I know that things like Unreal and other 3D packages, other DCCs are starting to try to implement MaterialX. So I try to stay away from the Houdini specific MaterialX nodes or the USD specific MaterialX nodes if you're trying to make this portable across different renderers or software packages. If you know you're just doing this inside of Houdini and it's going to stay there, then use everything at your disposal to make it as easy as possible. All right, so with this, we're just going to tell it what we want to bring in, what type it is. In this case, it's a float, but we want to go and grab that information. We could use debris. I'm going to use elevation to start out, and we're going to go ahead and just plug this into this mix node, and this is going to go there. Now, here's the thing. This works great for our surface, but what about our displacement? We need another mix node, and this one will stay afloat. And I'm just going to drop it right next to it here, and we'll plug this in the exact same order. Okay, and then we'll plug this in here. And now these should match. Okay, so we'll plug this into the top. We'll plug this into the bottom. And hit save. Always good to save. And let's see it render. Okay, there we go. So about 1:42. And this is using our elevation, and I can see that I really want these inverted. For clarity, what I would do is I would do this, and I would move this one above. I would try to keep my foreground always above and my background always below. I'd move this back up here, move that there, we'll move all these friends up. There we go. And now I would just switch these. And I know there's a hotkey to do this, but I can never remember. So I'm doing this in the absolute wrong way here because I didn't pause my render. I just did that all while the renderer was listening and being like, wait, what did you want to do? Okay. And we can see here we've got some great displacement here on the snow. We can see that it looks a little weird as it kind of fades, but we'll work on that. We'll get that to an interesting place. Okay. And there we go. So the displacement here is most likely we're pushing the displacement way too hard, for one. And then two, the quality of our displacement is too low. So it needs to have additional displacement to be able to capture some of that finer detail from those texture maps. Because when we shrink this way down, we get a whole bunch of different textures in there. So a whole bunch of detail in there that's hard for it to capture all the way down. So this is great. We've got the beginnings of something here. So this is now, at this point, we're at kind of the same thing that we were at before with Karma. We've got kind of our workflow, and now it's just building up based on where we want those shaders to be. The biggest problem right now that we have is our displacement's a little weird, and then how do we deal with some of these areas here? Well, before, inside of the material, or inside of the geometry, we would crank that and get that really tight. So how can we do that now here? Well, one of the quick and easy things to do is we can put down a ramp node, right? And in this case, it needs to be a float, right? We can tell because this is a float. All right, so if we drop that down, we can see here if we mouse over there, we see at the bottom it says out float. Okay, so we now just connect these in. And connect that there. This here. Now, one thing I've noticed with this ramp node, if we come here, we normally have all these great, like smooth. Oh, it tried, right? It tried. It really did. It really did. But it couldn't do it. Maybe if we come down here, okay, we'll set this to be Bezier. Oh, no, it couldn't do it. Maybe the first one needs to be Bezier. Nope, couldn't do it. There's got to be some trick in here, or it's a bug inside of Houdini that they need to address, that this stuff isn't working properly. So even that, like steps, there's been a couple times that I've wanted to use that and it doesn't. So you manually do it, right? You would come here and grab a knot and do that. You'd come here and grab a knot and do that, grab a knot and do that, and then check it out. We just made steps. Woohoo! Right? Not what I want for this though. So I'm gonna go ahead and get rid of this. We'll clear this out just by hitting linear. And now I'll come here and do something like maybe like this. Oh, I just killed it. Do that, and then just throw a couple little things in there to give it a little bit of a graduation, or maybe I want the graduation to be this way. We'll see. So now the goal here is we want to adjust this kind of really soft fall off. And there you go. So all that kind of really mushy stuff kind of just, goes away, and we now have kind of control. And the cool thing about this is now we can control within the shader of where we want that stuff to happen. So additionally to this is like, we might have this where it's like, it just feels, maybe let's pull this real tight. right? So this is now going to, really try to just, pull that up. And we could even get rid of some of these extra knots here. All right. Give that a second. Awesome. This is kind of the idea here. Now, when I look at this, it's like, well, the problem is it's not super interesting in that edge. And there is even still a little bit of that kind of sawtooth thing happening there that's not super awesome. So how can we deal with that? So this is where we can do this also in regular Karma, but it's a little messier here. And the nodes are just different. The nodes are different. I love using the turbulence node in my shaders. So what I'm going to do is I'm going to drop down a MaterialX, and I'm going to come in here and look under procedural 3D. And we've got a bunch of noise patterns here. There's noise, there's fractal, unified noise, Worley noise. I think what I want is a fractal, I think. So I'm going to drop this down, and I'm going to go ahead and just plug this in, and we're going to see what that does. All right, so there's my pattern, right? And holy smokes, that's really high frequency, which maybe is what you want. Maybe it's not what you want. I don't think it's what I want. What I'm going to do is I'm going to plug into the position here. I'm going to do just like we did with the UVs. I have to trick it. I have to make the renderer think that the position is someplace else for the noise field. I would love that there just be like a scale on here or like an element size, but you have to trick it. So you're going to put down a position node, right? So this is like bringing the position, point position in. So you're going to read that in, and you can do it off the object space. You can do it off the model space, world space. I'm not sure what the difference is between object and model. Ideally, if you're doing this for like a thing that's going to move through your scene, you'd have a rest position that you would bring in, and that would be brought in with a geometry property value. Okay, so I've got my position, and now what I'm going to do is I'm just going to put down a multiply node like we did with our UVs, and I'm going to plug this into the position here. And similarly, I need to make this feel bigger, I need to mult down my position, right? Because this pattern exists in three-dimensional space. So we're going to essentially take inside of the shader, we're going to shrink our model down, calculate this pattern, and then put that on the big scale model. See? Ta-da! So now we've got a nice, little noise pattern here. And again, we could, go smaller. I probably would. I'd say like 0.025. And then that's gonna recalculate. And we have the same problem here that we have kind of this like soft transition. So the way we deal with that is we can either use a ramp or we can use a fit node, right? So this is probably now too big. That's okay. I'm gonna show you. We're gonna get there, and you're gonna see this. It's gonna be this node madness, and you're gonna be like, "Oh my goodness, why would you do that to yourself?" Well, it's because when you love proceduralism, you do dumb things. So let's actually, I'm gonna change this. Let's make this 0.025. Let's make this 0.05. So really quick, I'm going to use another ramp. I'm going to paste this, and I'm going to plug it in here. And then what I want to do is I want to create like a range. Like if you remember what we did here, it gave us like a really sharp kind of edge. And what I want to do is kind of access the stuff that's hanging down, right? That's good. That'll work. So I'm going to put down another ramp, and this ramp is going to come off right off of our attribute here. And let's plug this in so we can kind of see what it's doing. And this ramp, I'm going to do something silly like this. I'm just going to pull this off, and I'm going to do that. And this can be let's make this 0.99, and this point, instead of being 1, is going to be 0.995. And what we're going to see here is this is going to eliminate. We basically took everything that's a value of 1 and we got rid of it, right? So we're going to get rid of that. And now we've got this extra little area here where it's like, awesome, we've got this kind of little space. Now I don't want it to do this graduation thing again. So what I'm going to do is I'm going to take this and just crank that up, and then I'm going to grab another knot and do this. And you're going to see that it gives us this kind of band, right? That is this like mid-range band. Right? Ta-da! That's already a little cool. It's got some kind of cool shapes. But now we can take this and we're going to multiply it against our noise pattern. Okay. All right, so there we go. So now we've got kind of this like breakup range where we get kind of this, you know, these distinct shapes instead. So it's not just a straight line. Well, now we can take this and we can put those back together, and we use under compositing. I've used a couple different things. I've used an over. You can use a mix. Let's try. Oh, these all want a mix channel. Let's try. All right, well, we're just going to do a mix. So what we need now is we need a third mat, which is this. So we're going to copy this and paste it, but we don't need this last little friend there. So that way it's white all the way to the end. Okay, and so we're going to plug in this to our mix. Oh, nope, that's not right. When in doubt, do it the simple man's way. So we're going to plug in an add node here, and we're going to use this here, right? Yep, that's our just our top of our thing here. And we're going to plug all of this into a clamp. Why? Because I just don't trust it to not output a value greater than 1. And when you're doing mathematics like this on mixing on alphas in comp, it's the same thing. You don't want to have that. You want this to be something that is 0 to 1 always. Okay. So let's let that cook. And there you go. So now we have this top area, and we can now set kind of this blend. There's a little line, this little weird gap here that we're getting. We could take this and expand it right on one of these, and just so that we don't ever have that, right? So we could actually take this now and get rid of this bottom one. And what that'll do is it'll make it so this noise pattern goes all the way up, but because we're adding them together but then clamping it, it gets rid of that little line, right? But doesn't really affect the overall. So this is compositing at this point, right? We're doing compositing on masks just in 3-dimensional space. So now I've got this kind of set up, and once I've got this, I can come into my noise pattern and I can start playing with some of this stuff to try to get more interesting patterns out of this that I couldn't get using the geometry, because you just have to have such heavy geometry to break up those edges that it wouldn't work. You can see here we got a nice little bit of extra breakup there, so maybe that, a little bit more lucunarity. I don't know how to pronounce that word. I'd be fascinated to look that up. But there you go. So now we've got this ability to kind of create interesting textural breakup to these edges, so we don't get that kind of CG, because it's all about having that really detailed CG edge. Now the reality is, up here, I would want there to still be some, some stuff coming through. That snow usually is not going to stick to everything quite so perfectly. So there's another trick that we can use, which is we can use the normals to find out what direction the surface is in. So let's look at that before we move on to growing this out. So I'm going to go ahead and just move up this guy here, sorry, and this one here. So just to give ourselves a little more space to operate. And I'm going to put down a normal node. And you're going to see that that comes out as a color, right, or a vector. And so what we want to do is we want to separate that out so that we can get access to the red, green, and blue channels, which are the X, Y, and Z coordinates of the normals. Now I'm going to use a clamp node because I really only care about 0 to 1 because if something is less than 0, it's facing downward, which it shouldn't be in this because it's a height field, but just as good measure, I'm going to put that clamp down, and then I'm going to put down another ramp, and this will be a float ramp. And what this would be doing is at 0, where the normal is 0, it would give me a black mask, and then wherever it's 1, it's going to give me a white mask. And so I'm going to go ahead and plug those in. Let that cook for a second. All right, so there, that's coming in, and man, this displacement is so ugly. Let's just turn that down. Let's make it like a nice little value of 2 or something. Although I kind of like it right here. I just don't like it in these kind of soft areas. It kind of blows stuff up in an interesting way. So 2 might not be enough, but this is fine. We're gonna go with it. So now we can come into this mask and we can just start playing with this. So this would be saying that everything that is at a value of 0.75, so that's like a 0.5 would be at 45 degrees to the horizon. So this would be 60 degrees, I think. It's going to make that everything below that is going to now yield a 0 value. So we'll see like all of this area. All of the sides of this is going to start coming in using our pebbles instead of our windswept snow. All right, so there you can see this is a really great way to get a really cool look. Now the awesome thing about this is it takes into account the underlying displacement to get that normal. So this starts to look really interesting as we're trying to get kind of that look of maybe snow, or if you wanted the tops of your rocks to have a sense of like dirt, you could use the gravel on top and then like more of a rock on the sides. And then, then it's just a matter of coming in and balancing where we want that to fall. And you get this interesting kind of snow look, between those. And there you go. So now I could take these two things and now I could multiply these together. So I can come here and I can say multiply, and we'll plug that into one, plug this into the other. This was our previous setup that we had, and plug them into both of these. Let that restart. And there you go. So now, you don't necessarily have to be, this, again, it goes back to compositing. We're really just compositing all of these different things together to find where we want these different materials. So, I would do another setup here since this is my kind of this rocky texture. I really only want this in a few places. I want really like a bigger rock look. So I'm going to do one last step, and then we're gonna call this good as far as where we're going for today. All right, just copy and pasted down another one. I'm going to jump back out to my material network, and on this, I wanted that this Icelandic cracked rock, and we should see that now I've got 8K. That's why it looks like that, which is great. We do. So I'm going to cancel, and I'm just going to grab everything before that 2K, and I'm going to copy, and I'm going to jump back over to my mountain material, come to this fun friend here. Sure, we'll start here, paste 8K underscore normal. Oh, it didn't grab. As you can see when I hit enter there, oh, come on, friend. It started the render again. Turn that off, because that'll get you every time. It really does. So we're gonna come back out here, and I'll paste here 8K. This is gonna be albedo. Paste 8K. This is going to be specular. 8K, and this is going to be roughness. Awesome. And then our last one is going to be our displacement. All right, so now we've got these two going. I've got a bunch of different kind of things that I can use. I'm going to use a geometry property node, and I'm going to use that occlusion that we generated for now. And again, I would go through and add actually many more layers than this, but this is, again, just to get the idea. And so these all right now feed into this material mix. And now I'm going to mix these two together, and then they're going to feed into that. So I'm going to put down a mix node. Let's do 2 of them. So I'll just copy and paste that. So the first one will go here, and the second one will go here. And I'm going to go ahead and before I even hook this up, I'm going to put down a ramp float, because I know I'm going to use that to adjust this. And I'm not going to go into this whole thing. I mean, I could just copy this. In fact, let's try that. Let's actually try this. Let's see how easy it is. We're just going to copy this whole setup, and we'll paste it here. Drop that down. Just kind of keep our node graph clean. Ideally, I'd be dropping down network boxes and all kinds of stuff to help this feel a little easier to read. So we'll put that there, and we'll put this here. See, this is messy to cut through like that. Not ideal, because, you know, if somebody inherits this and they're trying to track where all this stuff goes, it can get pretty messy pretty fast. So it's really good to use knots and dots and, you know, whatever you want to call them and all that stuff. So we're going to come back to our geometry property value here that we copied down. Instead of elevation, we're going to use occlusion. I also made a floor that we could use. In fact, we'll use floor. Let's try floor instead of occlusion. And I'm just going to hit save, and let's go ahead and take a look at what this gives us. All right, so very exciting. You can see here we've got an error. This is the log viewer. You open it up by hitting the plus sign, new tab, log viewer. And so as the renderer logs errors, you can see there's 3 errors, see log viewer pane. We can see what this is. So that's the error. That's the critical error. These are warnings. And then this is what's stopping it. And it says that the shader graph has a root node type not handled by XPU skipped. I was like digging into that. I thought, oh, it must be that we have the EXR textures in there. So I took those ones out and put in the JPEGs, and because it didn't do the conversion, those didn't work. And if I change things around, I could get it to render so long as I didn't use this material mix node. So I dropped down another one, rebuilt it a couple of times, always did the same effect. So in going to the internet, there is a feature that is missing. So it's according to according to side effects, it's an incredibly hard feature to implement. It requires a ton of rebuilding. Sadly, this makes XPU really not as flexible, because it's really nice to be able to set up a shader and then mix those together in the way that we're showing. There is a workaround though, however. So we've gone through all of this to learn all this great stuff, and now we're going to learn a workaround for this particular error. But it's good to know that this error exists. I'm learning it with you. And how can we deal with it? Well, just like we're just mixing the texture for the displacement, we could mix our shader, our textures going into our standard surface. So it's really going to take a couple of, looks like 4 on each of these 4 mixed nodes. So let's just do that. Let's see how fast we can get this done. I'm going to turn off the XPU, and I'm going to pause this so you have to watch me build all these, and then we'll see if it works. Actually, maybe we'll build this together. So as I've got this pulled out, so this is going to be what goes into my final shader here. So we'll plug these guys in. This goes into my roughness, and this goes into my tangent normal. And I know that I am initially mixing, I don't want to connect anything, don't connect. I'm initially going to mix this texture set. And so I don't need this shader anymore. So I'm going to delete this shader, and I'm going to delete this shader, and I'm going to delete this node here. And I really don't need this mix anymore. This is what's connecting. Let's see if I can get this to. We'll grab the mix node here of all of these and come back to that input. Awesome. I don't need this anymore. So this will be our shader. And, oh, I might have messed this up. Let's see, those are mixing. Right, so this mix is coming from here, which is driving that, which is great. And that's our FG, and then our BG is this guy here. So we're gonna have another set of mixes right here. So I don't need these ones. So these will come here. We'll do a mix is going to be to this mix here, right? So we're going to match that. So this FG is going to be here, which is going to be our base color, our specular color, our roughness, and our normal, all into the FG of those, right? The foreground. And now the background of those is going to come from down here. So we'll just grab our base color and come up. It's actually not that bad to set this up. The problem with it just is a visual mess. Just not very pleasing to look at. Come on, side effects, you guys can do better. Okay, so that does it, and then we have to connect these guys in. So these come up here. So that's foreground. This is going to be that one. Goes in the background of that one. Goes in the background of this one. Okay, this will get so confusing to look at. It's going to take a lot of kind of managing this. I wonder if you can do subnets with multiple outputs. We can test that. But in theory, now we've just pushed this all through so it goes through into one shader. So let's check this out. Fingers crossed. And it does. It does what we want. So there's my dirt, here's my mountain, and here's my snow. So I mean, look how quickly we were able to adapt to that problem. One of the cool things about Houdini is its adaptability. Again, I like this a lot less just for the visual complexity of how to do this. It would be interesting to write a node where you, just like this is a kind of a collection, to write a MaterialX node where you could just kind of pare this down into a set. But there we go. So, you know, here now we have this thing that if you look at this, this has some pretty nice looking visuals to it. I don't love how hard the transition line is here on some of this gravel stuff coming out of that, but you know, we could work on those. But already this to me feels pretty interesting, and it's really only 3 texture sets. It's pretty spectacular what we're able to achieve. And then to adjust this just really comes down to now playing with some of these ramps, if you can remember what they all are. Another feature that's really cool in Karma is you could put down a bind export. I'm sure there's a way to create AOVs, so let's type in AOV. Nope. So we'll research that some more, and we'll see, because it, you know, one of the great things is to generate masks for all of these that can then go to comp. So the compositor can push around particular materials, be able to make adjustments, and that's really helpful. So we'll talk about that hopefully next week. But the goal here is to push for additional visual interest, right? Increasing the complexity of our underlying surface can do some really cool stuff, and then also as we blend in our different shading materials. And you know, this is a nice, really fast render that we've got here. So let's see, this is my ramp, right? This is my elevation, and this is how I'm mixing it. Yeah, so this is setting how far down it goes. So if I wanted to get more out of this, I could just grab and this should push down how much snow is happening here. All right, there we go. So we push down a little bit more to get a little more out of that elevation. And again, we could go in and add additional noises and things to kind of boost this up. I could use my, again, it's just building of masks. I could take my occlusion, so I could use geometry, property value here, and occlusion, and let's see here. I believe that what I want to do is I'm gonna merge it with this, because this one here is using our normals. So I'm gonna actually just do the same kind of clamp and add, right? So we'll clamp, and so we're gonna do also an add node. And so what we're gonna do with our normals is we're gonna take our occlusion and we're gonna multiply it we're going to multiply it by this one here. This is just this kind of topmost thing. If you go back and look, it was the kind of the isolating the topmost part of our graduated mask here. And so I'm going to multiply those two together. So it'll only give me the occlusion up here in this area, so I won't give it down here. And then we're going to take this, which is our snow, right? Our normal kind of mask that gives us this cool breakup. And we're going to add these two things together, and then this has the clamp on there. And what we'll see is we're going to get like more snow up in these areas, right? And it'll kind of fill in some of these crags and stuff like that, where the idea is those deep kind of pocketed areas that have occlusion are going to hang on to their snow a little bit. Now, I would then want to take this occlusion and multiply it again against, so we'll just paste this, and we'll use our direction attribute, right? Because this looks a little CG to me. And so we have to multiply again another one. So we'll just drop another multiply in there. And we'll multiply this against our direction. Now, in both of these, I probably want to put a ramp on here so that way I can, get rid of some of that fade. I don't like that fade. It doesn't do the right thing of what I would expect. But, maybe it's an overlay. Maybe, honestly, those are like really Photoshop kind of things. I'm not a Photoshop guy. I've never been a Photoshop guy. I remember people making their Christmas cards in Photoshop, and I would make my Christmas cards in Shake because I preferred a node-based compositor versus what I had. So here we go. Now we've got that occlusion only where it's kind of in this, this direction that's coming from, one side. Again, there's no right or wrong here. It's about understanding the rules you're trying to create and why. Maybe we'll leave this and we'll put a ramp node just for one last thing, just for fun. We're wrapping up here. Let's just do one more, and we'll just drag that, kind of pull these together. And then what I expect is that's going to sharpen up those edges of that occlusion. Now again, I would then want to kind of go through this same big thing that we did with the elevation. I would do that to the occlusion, and I would change the frequency of that so that way I got something that felt good. But you're starting to get stuff, right, that feels interesting. The normals really do the most work here, where they really add a lot of interesting visual breakup to that. So, but here we're starting to get something that is feeling like a usable background. So I hope you found this instruction helpful. The goal here is using MaterialX. It opens up a whole new world of using our GPU versus the using Karma and the CPU. The reality is for very, very large scenes, you may find that you tap out on your GPU and it just is too heavy. I do believe that the XPU will allow you to render on the CPU as well. You can see here where it says optics. Those are my 4 graphics cards, and where it says Embry there, that is the CPU that can be involved. And there's actually an environment variable that you can set that will turn off the use of a graphics card, or will turn off the use of a CPU, or you can have a mix of the two. So next time we'll still look at a little bit more at how do we plus our actual geometry, and we'll start getting into scattering of assets across that environment surface. We'll also look at how do we up-res certain sections, so pieces that are closer to our camera, how do we take those, and then based on our rough-in, how do we then level that part up? Or how can we design our scene so that way we can have a foreground, a midground, and a background to help us with our setup. So hope this helped, and see you next time.